Section 2.4 is called Operations with Functions. In particular, there are 4 operations that you are very familiar with, and you've been familiar with them since early elementary school. What are your 4 basic mathematical operations? Addition, subtraction, multiplication, and division. And you've used them on numbers forever. I mean, really, forever at this point, like your whole life practically, right? Yeah. So what we're using them on in this section, those operations, though, is to operate on functions. In particular, we're going to add functions together, subtract functions, multiply functions, and divide functions. And they work just like you would expect that they work. And then we're going to throw in an additional operation after that. Yeah, you thought it was going to stop there. Sorry about that. Okay, so here are directions, and I'm going to show you how it works by giving you like actual examples to show. Find each of the following. Okay, so we're going to find A through, this is going to be A through H. Yeah, for real. And we have 2 functions. We're going to use the same functions almost the whole, well, for this whole problem, number 1. X minus 3 is the function f of x, and x squared minus x is the function for g of x. Okay, so jot those down. Okay, notationally, it looks a little bit funny, but notationally, what this means is that I'm going to take the function f, and I'm going to take the function g, and I'm going to add them together. Well, I mean, like that's what it says, right? The 3 after this means that I'm going to evaluate it where x is equal to 3. So another way of writing this that's at least a little bit more clear is to say I'm going to find the function when 3 is plugged in for x, for f, and I'm going to do the same thing on the function g, and then I'm going to add them together. So taking a look at your function f of x, which is x minus 3, if I were to plug 3 in for x, it would look like 3 minus 3. And if I were to take the function g of x and I were to plug in the 3, it would look like 3 squared minus 3. And then the operation that it's telling me I'm supposed to use here is addition. So I'm supposed to add those quantities together. So what is 3 minus 3 plus 3 squared minus 3? It's 6. And your calculator can do that, or especially if the numbers get messy to work with or whatever, or you do them in your head, it doesn't bother me. But what I've written on my screen right here is exactly the bare minimum that you need to write down. That's the bare minimum for what we just did. Okay? So you can't skip any of what I just wrote and actually show that you know the process is working and how it's working. Less than that means that you, worst case scenario, you looked on somebody else's paper. So, okay? So show me those steps so that I know that you're thinking the right way. All right, so on the second one, you'll notice that there's a subtraction sign instead. You also notice that there's not a 3, there's a 5. Okay, the number at the end just tells you what x is. That's all it is. It's just telling you what to replace the x with. But the sign between tells you what to do with those results. So this is telling me I want to take my function f and plug in 5, and I'm going to subtract my function with g plugged in with x equal 5. All right, so this is something you're writing down, and bare minimum again means I'm writing down 5 minus 3 here, minus 5 squared minus 5. Now, if you want to write another step for simplifying little pieces of this along the way, that's great. If you want to go straight from here to your calculator, or straight from here to calculating in your head or writing it down on a scratch piece of paper, that's fine too. What is 5 minus 3? It's 2. What is 5 squared minus 5? 20. And what would 2 minus 20 be? Negative 18. Okay, so maybe you write down the 2 minus 20, maybe you don't, but at the end you get negative 18. What does C tell us I'm supposed to do? Multiply. And what's the negative 2 telling me? That's my x value. Exactly. So I'm going to multiply my functions where x is the value -2. So I have f of -2 times g of -2. Okay, this one's just a little messy because of all the negatives involved, so be careful with the negatives, just because they kind of bite you in the butt sometimes with the signs. But this is -2 minus 3 for the f of x function. And then here's where we've got the signs that we need to be careful of. We have -2 squared minus -2, right? Lots of negatives there. That's the bare minimum to write down. You can calculate otherwise after that, however you choose. I'm going to write mine down just because it's easier for me to keep track of them. -2 minus 3 would be -5. What's -2 squared? 4, and then minus a -2, right? Plus 2, so that's 6, right? So I've got times 6 here, and -5 times 6 would be -30. Okay? This one's -30. I've so far added, subtracted, and multiplied, so what's next? Divide. Yes, it is. Ignore E and F for the moment. D is to divide. Notationally, again, this means I've got f of -4, because -4 is my value for x, divided by g of -4. So this is -4 minus 3 over -4 squared minus -4. What's my numerator? -7. And the denominator, I got lots of negatives again. -4 squared would be 16. And then I have minus a -4. That's plus 4. So 16 plus 4 would be 20. Now, if in fact the 7 and the 20 were reducible, like let's say it said 7 on top and 21 on bottom, we would need to reduce it, okay? This one, they're simply not, so we're done. So far, so good? All right. I've got 2 of the next 4 that are on the screen. Tell me how they differ from what I've done already. There's a variable instead of a number. I don't have a number at the end in parentheses. I have an x at the end in parentheses. Does everybody see that? My opinion is that this makes the problem easier. And the reason is because it means I have less calculating to do. All right? There's less work. Now, on the flip side, it means that I don't have a numerical answer at the end. I don't have an equals 5 or an equals 7 over 20. There's not a number at the end. I still have variables at the end. But the calculations are easier. So notationally, this means the same thing it did before. I'm adding the functions together. I just don't have to worry about plugging in x. It's f of x plus g of x, and that's all it is. So what is f of x? It's x minus 3. And what is g of x? X squared minus x. And all I have to do is combine like terms. Okay, so what do you get if you combine these terms that are alike? X squared, and then what? It's not minus 2x because one of them's positive and one of them's negative. So it's just minus 3, exactly. This one actually simplifies by those canceling out. So I just have x squared minus 3. No need for a calculator, no need for the numbers being evaluated. I don't have to worry about negatives because I didn't put a negative in anywhere. So the process is a little bit cleaner. On the second one, it says that what am I supposed to do with my 2 functions? Subtract them. So this is f of x minus g of x. F of x is x minus 3 minus, and g of x is x squared minus x. So what do I have to be careful of here that I didn't have to be careful of before? Distributing that negative, right? This negative makes sure to distribute to each of the terms on the inside of the g of x. So I have x minus 3 on the first piece, that's fine, but then I have minus x squared and positive x. It's easy to just overlook that piece. Don't overlook it. It matters. Now when I combine like terms here, what do I get? Right. There's the x squared plus my 2x this time. But then I still have minus 3. Thank you. I was not catching that when you guys said it, but you did say it. Yes, negative x squared. Thank you. Okay, any questions on that? What do you think we're going to do next? We're going to multiply them. You got it. F times g. So, f of x times g of x. Remember, I'm writing down almost on every single problem the bare minimum I'm expecting to see. I expect to see f of x times g of x written just like I just did. F of x was x minus 3. G of x is x squared minus x. So, what do I have to do? FOIL, distribute, multiply it out, right? So if I distribute and I multiply this out, first, outer, inner, last, the first terms are x cubed. What's the outer term going to be? Negative x squared, right? How about my inner term? Negative 3x squared. And the last terms? Plus 3x. And then I need to combine like terms, right? I'm going to move that over to the other side. Usually the highest exponent comes first. That's the x cubed. If you don't do it that way, it's not a big deal, but just typically see that. How many x squareds do I have? I have negative 4, right? They're both negatives. I have a negative x and a negative 3x. Negative x squared and negative 3x squared. So I have negative 4x squared. And then what do I have? That's then plus 3x. What do you notice is different about h? There's a word domain written down. We didn't have that before. Yeah, so there's a reason for that. Any guess as to what the reason might be? Like, why did we not have it before and now we do have it on this one? Because it's division. That's part of it, right? And I did one other division problem. That's the other piece. Very good. So there's division, and there's still a variable in the problem. Right? I had one division problem before, but it had numbers all in it, so I don't have to worry about it. So let's do the division first, and then we'll talk about the fact that it said domain. So this says I'm going to do f of x divided by g of x. And in some ways, this is a very nice problem because there's not any simplification. F of x was x minus 3. G of x is x squared minus x. And these don't simplify. If they could factor and reduce, that'd be great. We could factor and reduce it, but they don't on this one. I'm done. Now, what kind of domain issues could I potentially have when I have a denominator present in a problem? Yeah, denominator equaling 0 is a big no-no, right? We don't divide by 0. It's an undefined operation. So what we need to do is we need to figure out where, in fact, this denominator does equal 0. So if I set this equal to 0, what is the way in which we have found, there's been more than one way, but there's a natural way on this one to do this. You could graph it. That wouldn't be a bad way of doing it. I think there's a quicker way, though. Factor is probably going to be our quickest way from where we are. This one actually has just two terms, and they both have something in common. What's in common to x squared and x? X. So I can factor an x out in front, and if I factor out an x, what am I left with? X minus 1. I can set each term equal to 0, right? So I have x equals 0, and I have x minus 1 equal to 0. If I add a 1, I get x equal to 1. If x is equal to 0, or if x is equal to 1, the entire denominator will become 0, correct? Okay, so remember when we're writing domain, we're trying to say what we can have, not really what we can't have. So my domain is actually all x but or except x cannot equal 0 and 1. That's the domain that we've got going on. All of the x's except for not allowing. Yes, Spencer?
If you just wrote x does not or cannot equal 0 and 1,
It would be, you'd still get something, like if I were grading it by hand, you'd still get something taken off because you haven't identified that everything else is okay. And domain is really like what we're supposed to be saying is what is allowed. So you want to say that the other x's are okay as well. So yeah. So most of the credit you'd be getting, but you'd still miss a little bit of what's going on. Yes, Lena?
Is it okay for us to say all real numbers? Like, is that okay?
You can say all real numbers except. Yeah, so like you could say this. That's the real number sign.
Okay.
The E means is an element of, or it's included in.
Right.
It's among those values. Yep, you could say that. I have no problem with that. I'm not sure what symbols you're gonna show up inside of my math lab, but
Right.
it's certainly a valid symbol. Yeah. Okay, we've covered 4 operations, but I told you that we were going to cover 1 more. Remember that? We are at that point in the lesson, the 1 more lesson, okay? All right, that 1 more operation is called composition. So composition is the idea of taking a value and putting it into another function, okay? So taking one value out of one function and putting it into another one. So some people look at this and they think it looks like fog, F-O-G. That O is sort of like smaller. It's really not an O. It's not a full-size O compared to the F and the G. It's smaller. Almost the size of a degree symbol, but just it's in the middle of the line instead of above, like a superscript would be. But what it's defined to be is F is on the outside and the G function is on the inside. So G is sort of inside of F. I changed the functions. We're going to work with slightly different functions on this one. F of x is the square root of x. G of x is 1 over x plus 3. Okay, so taking a look at this, what this is telling us to do, there's a couple of ways I could show you how to do this. I'm going to show you how to do it sort of working from the inside out, kind of like that method. So if you notice the inside function is g. It's the one that's one of the ways you can think about it is it's the one that's the most closely related visually to the 2, okay? So what we're actually going to find is a 2-step method. Step number 1 is we're going to find what is g of 2. Okay, we already know how to do that. We've been doing that now for several lessons. What do I do to find g of 2? 2 for all the x's in the g equation, right? My g equation is 1 over x plus 3. So this would be 1 over 2 plus 3, which is 1 over 5. So far, so good? Just found g of 2. The second step, this is the new step, is to take that answer and to plug it into the outer equation. Okay, so the 1/5 was the answer, and it's now going to be the input for the other equation. So I've got f of 1/5. So the function f of x was a square root function. In place of the x, I will now put 1/5. We learned back in chapter P, that was y'all's favorite chapter, that we could separate radicals. We didn't learn it, we just remembered it. We can separate radicals like this, right? Square root of 1 is 1. Square root of 5 is irrational, so we don't leave it in the denominator. How do I get rid of a square root of 5 in the denominator? Yeah, you multiply by the square root of 5. On top and on bottom. So this simplifies to square root of 5 over 5. It's just a double input. That's all I did was a double input. Input the first value in the inside function, take the answer from that and insert it into the outside function. That's the answer. So we're going to do it again. But what I want you to see now is that what happened. I switched to the order. Do you think that it'll be the same? Will my answer be the same when I switch the order? Julia shook her head really strong. She's absolutely certain, and you're absolutely right, Julia. It will not be the same. Now, in some obscure example, it might randomly sort of work out kind of thing, but in general, no, it's not going to be the same. So again, the piece that's most closely associated together, the function f with the number 2, says that I'm going to take my function f, and I'm going to put in the number 2. So in this case, my function f is a square root function, and the 2 will go in place of the x. Then I'm going to take that and I'm going to let that be the input into the outside function, which is g in this case. In place of where I have an x now in the g of x function, I will replace it with the square root 2. So I have 1 over. The x is what comes next. So this is square root of 2 plus 3. But I have an irrational number in the denominator, right? Square root of 2. How do I get rid of it when I've got an irrational number separated with a plus sign like this? Multiply by the conjugate. Very good, Molly. So square root of 2 minus 3 would be the conjugate, right? So the numerator now has the irrational part with it. The denominator we can multiply out, right? I mean, really what we're doing is multiplying these two denominators together. The whole point in doing so is that it eliminates the radical because the inner and the outer terms are the same value but opposite signs. So it's the first terms. So it's square root of 2 times square root of 2. What's that? 2. And the last terms, positive 3 times negative 3 would be negative 9. And then 2 minus 9 would be negative 7. So as ugly of an answer, so to speak, as this is our answer for the problem. And it's not the same as the other direction on part A, right? The other direction mattered. Okay, let me do one more example, and then I will record when I get back to my office the last 2 pieces. It'll just be about 5 minutes, maybe not even that long. We're going to do the same compositions we just did, but we're going to do them without numbers plugged in. Okay? So what you'll do is the same thing you did on the last slide. You'll start with g of x, and you can even write it down the same if you prefer, right? G of x function. Well, g of x is 1 over x plus, 3. And then what I'm going to do is I'm going to take my f of x function, I'm going to plug this value in to the inside. Okay, so previously I put a number in there, but when I put variables in there, it's the same thing. It simply means replace the x with all this stuff. It's messier, but it's the same thing. In place of x, which was underneath the square root, I will have 1 over x plus 3. Now the reality is that that's a perfectly valid answer, and it's perfectly okay to have, because depending on what x is would depend on whether or not that denominator is actually radical, right? Some of them would simplify. So as far as I'm concerned, I'm fine on a quiz or whatever with you leaving it like this. I don't know what my math lab's going to make you do. So if my math lab doesn't like this, I want to show you a couple ways you can change it. Obviously, like we did on the previous slide, you can separate the radicals out, right? So you could separate your radical this way. You could also then have to multiply by the square root part, just like we did on the square root of 5 over here on part A, right? We could do that too. So if my math lab's freaking out, just multiply by the same square root of x plus 3 that we had from before, and you will have square root of x plus 3 on top, underneath the radical, and x plus 3 on bottom. And there's nothing wrong with that answer. I'm just not really sure that it's all that much better than where we began. Okay? So all of those are equally valid answers. Now, there's one more piece that we haven't done. We'll do it really, really fast. It says domain. The domain needs to be the x values that are allowed. And what I'd like for you to recognize is that there's a problem right here. Number 1, there's a denominator, just like we identified back on an earlier problem. Number 2, there's a radical, and it's a square root. What kinds of numbers are not allowed under square roots? Negatives. And because it's in the denominator, we're also not allowed to have it be 0, right? So the part that's underneath the square root, the x plus 3, needs to be flat out positive. Can't be 0 because it's in the denominator, can't be negative because it's in a radical. And if I solve this, which I will very quickly, I find that the domain is that x must be greater than 3. Thank you, negative 3. Get that negative in there. The process will work very similarly for part D. I'll post it online for you to watch later, and I have one more simple example after that to post as well. Okay, so watch the video at the very end. I'll just continue this one on for like 3 more minutes so you can just like zoom to the end to watch it, okay? All right, for the second one of these, we're going to just do this in the opposite order. So we'll start the same way. I'll change colors to try to identify the different pieces since I'm kind of all over my screen at this point. So my function f of x is the square root of x function. And then we're going to take that and we're going to plug that into the g function. So there's that square root of x going inside of the g function. My g of x function is 1 over, and then it was x, so the x will then be replaced by square root of x, and then plus 3. Now again, for me, this is totally a fine answer. There's nothing wrong with this. If my math lab freaks out, wants you to get the radicals out of the denominator or something like that, then you would be multiplying by the conjugate. The conjugate would be square root of x minus 3. And then your numerator, of course, would be the square root of x minus the 3. And the denominator would be actually x minus 9. Now, you do run into some problems again with the domain for this, so either of these expressions, which are okay. Obviously, your denominator cannot be 0. The square root of the denominator, let me give yourself some space, the denominator, which is the square root of x plus 3, cannot be equal to 0. But if you'll notice that pretty quickly, that means we've got the square root of x on the left, cannot equal negative 3 on the right. And then if you square both of these sides, then you're saying that the x cannot equal 9. But in reality, if you put the 9 into the denominator, it's just fine because that actually doesn't equal 0 in the denominator. So this doesn't yield a problem. It looks like it might, but that's one of those extraneous solutions that comes about. However, we do still have an issue with the square root itself, right? There's no negatives underneath the radical itself. So we do know that the x value cannot be actually negative. In other words, it has to be greater than or equal to 0 itself. So our domain for this one is that the x has to be greater than or equal to 0. Equal to 0 is okay, right? Because that would make the denominator actually equal to 3 if we had the square root part equal to 0. All right, we have one more function example. This is called decomposition. It's sort of moving in the opposite direction. So the idea is that we have this function that's been sort of composed together and we're breaking it apart into pieces where it looks like something has come from the inside of something else. So you'll notice over here that the notation says we're trying to find the functions h and g where the h has a g function inside of it. And my final function that I'm trying to get to is the 3 square root of x minus 1, right? That's my goal. So the easiest way to sort of identify this is to look like what's inside of something else. And it very much looks like that this piece that's the square root of x is inside of something. So it's a good idea to call the g of x the square root of x on this one. And then the part that would be stuffing it into, if you will, would be 3, right? That x, square root of x would be replacing the x, and then the minus 1. So if we're sort of breaking it apart and identifying like this, then you would find that g of x is equal to the square root of x, and then the outside function, which is h of x, would be equal to 3x minus 1. And remember, you can double check this by actually physically performing the operation. So if you put this inside or replaced the x, you'd have the f of x function that we were looking for. So that would be one solution. The one thing that you can't do on this, and I will say this right now, is you can't create what's called a trivial solution. So a trivial solution would be simply letting the g of x function be x. You can't just say g of x is x, because that doesn't actually break it apart any differently. Then that would mean that h of x is exactly the same as f of x, and that's not actually decomposing anything. That's just breaking it apart into two different functions that are neither one simpler than you had before.